Name of the chapter is error analysis. Number one topic is absolute error. Let A equal true value of a physical quantity. True value of a physical quantity. AM equal measured value of the physical quantity, measured value of the same physical quantity. Therefore, delta A equal AM minus A. That means delta A equal absolute error in the measurement of that physical quantity. That means delta A equal AM minus A. Number two topic is what we have to know what is a relative error. Relative error. The relative error is equal to absolute error divided by true value of a physical quantity. Relative error can be determined by dividing absolute error by true value of the physical quantity. Therefore, relative error equal delta A divided by A, where delta is the absolute error and A is the true value of the physical quantity A. This is relative error. Now number three is percentage error. Percentage error is equal to percentage error is equal to relative error into 100. That means we can find the expression of percentage error by multiplying relative error with 100. Therefore, percentage error equal to delta A divided by A into 100. That means percentage error in the measurement of a physical quantity A. So here it is written in the measure of physical quantity, but it should be in the measurement of the physical quantity A equal should be in the middle, equal delta A divided by A into 100. Delta A by A is the relative error and it is multiplied by 100. So we get the expression of percentage error in the measurement of the physical quantity A. Number 4, we have to discuss few formulae regarding this chapter, error analysis. And that is we have to apply to solve the numericals. Number 1, if y equal a to the power n, then it should be delta y by y, not delta a by a. We have to erase this one. If y equal a to the power n, then delta y by y equal n delta a by a. N delta a by a. Here the power of a, that is n, comes in front of delta a by a. Means this is the absolute error in the relative error in the measurement of y. Number 2, if y equal c dot a to the power n, comma, delta y by y equal n delta a by a. Here the term c, where c is constant, and c will be removed from the expression of relative error delta y by y. Yet there will be no c in the expression of delta y by y. Delta y by y equal n times of delta a by a. Power of a into relative error in the measurement of a is equal to the relative error in the measurement of y. Again, if y equal a to the power n dot b to the power m, product of two functions, then delta y by y will be equal to n delta a by a plus m delta b by b. That means relative error in the measurement of y will be sum of relative error in the measurement of a to the power n and b to the power m. Number 4 formula. Number 4, it should be number 4, 1, 2, 3, 4. If y equal a to the power n divided by b to the power m, that is y equal a to the power n dot b to the power minus m, y equal a to the power n dot b to the power minus m, then what will be the expression of relative error in the measurement of y? Delta y by y will be equal to n delta a by a plus m delta b by b. Though the power of b is negative, that is minus m, but here we have to consider plus m delta b by b. Here we cannot write minus m delta b by b. So it should be n delta a by a plus m delta b by b, which will be equal to delta y by y. Number 5 formula, if y equal a plus b, summation of two functions, then delta y by y equal delta a divided by a plus b plus delta b divided by a plus b. Number 6, delta y by y equal to delta a by a plus b plus delta b by a plus b. Both should be divided by a plus b. Number 6, if y equal a minus b, that means y is equal difference of two functions, then delta y by y, which is the relative error in the measurement of y, will be same as that a plus b, same as the formula of a plus b, and that is delta a by a minus b. Here in place of a plus b, a minus b plus delta b by a minus b. Delta b by a minus b. Finally, we get delta y by y as delta a by a minus b plus delta b by a minus b. Number 7 formula. If y equal a dot b divided by a plus b, then delta y by y will be what? Here y is actually delta y by y equal to delta a by a plus delta b by b plus delta a by a plus b plus delta b by a plus b. Actually y equal a dot b dot a plus b whole to the power minus 1, product of two functions a plus b to the power minus 1. Here the denominator a plus b comes in the numerator as a plus b to the power minus 1, and finally we get delta y by y as sum of four quantities. Now we have to consider few special cases. Number 1, the area of a sphere of radius r is given by a equal 4 pi r square. 4 pi is the constant. Pi is 3.14. If we consider a sphere of radius r, not capital R, it should be small r, then area A will be 4 pi r square. Therefore, delta A by A, that means relative error in the measurement of area, will be equal to 2 delta r by r. Here the constant term 4 pi will be removed, 2 delta r by r, and that 2 is actually the power of the radius r. In the expression of area A, we have 4 pi r square. R square, the power of r is 2, and that 2 comes in front of delta r by r. 4 pi is constant, that will be removed from the expression of delta A by A, and the power of r, that is 2, will come in front of delta r by r, that is 2 delta r by r. Relative error in the measurement of area of a sphere is twice of relative error in the measurement of its radius. Finally, we get the expression of relative error in the measurement of the area of the sphere. Relative error in the measurement of the area of the sphere of radius small r. In diagram it is capital R, but it should be small r. Number 2 formula is the volume of a cube. Number 2 formula, special fact is what? Special case, the volume of a cube is given by capital V equal L cube, where L is the length of each side of the cube. Where L is the length of each side of the cube. Side of the cube. Therefore, delta V by V, that is relative error in the measurement of the volume of the cube, delta V by V equal 3 delta L by A. Now V equal L cube, the power of L is 3. The power of L is 3, and that 3 comes in front of the delta L by L. That means delta V by V equal 3 times of delta L by L. volume of relative error in the measurement of volume of the sphere is 3 times the relative error in the measurement of the length of each side of the cube, 3 delta L by L. So this is the expression of relative error in the measurement of volume of a cube. Measurement of volume of a cube. Of the cube. Therefore, if we want to find the expression of percentage error, therefore delta V by V into 100 equal 3 delta L by L into 100. Into 100. This is the expression of percentage error in the measurement of the volume of the cube. Delta V by V into 100 is the percentage error. Percentage error in the measurement of the volume of the cube. Number 3, the equivalent resistance. The equivalent resistance of the parallel combination of a parallel combination of two resistance R1 and R2 is given by of two resistances R1 and R2 is given by Rp equal R1 dot R2 divided by R1 plus R2. That is from the expression of reciprocal of equivalent resistance 1 by Rp equal 1 by R1 plus 1 by R2, we get Rp as R1 dot R2 divided by R1 plus R2. And here we can draw the diagram of parallel combination. Two resistances R1 and R2 are connected in parallel combination. That is shown in the figure. R1 and R2 are connected in parallel combination. Therefore, delta Rp by Rp into 100. Delta Rp is the absolute error in the measurement of equivalent resistance divided by Rp is the true value of equivalent resistance into 100. That is the percentage error in the measurement of equivalent resistance is equal to delta R1 by R1 into 100 plus delta R2 by R2 into 100 plus delta R1 divided by R1 plus R2 delta R1 divided by R1 plus R2 into 100 last two terms will come from that term R1 plus R2 delta R2 divided by R1 plus R2 into 100. That is important. That is an important concept into 100. So finally we get the expression of percentage error in the measurement of equivalent resistance Rp. Rp is a product of three quantities R1, R2 and R1 plus R2 to the power minus 1. But for the percentage error in the measurement of equivalent resistance, it is expressed sum of four quantities which is equal to delta R1 by R1 into 100 plus delta R2 by R2 into 100 and sum of other two quantities, and finally we get percentage error percentage error in the measurement of the equivalent resistance RP. Equivalent resistance RP.